So we've spent the last 2 lectures finding z-scores, and then we would find the probability based on that z-score, and it might be the probability that we're falling below that z-score, above that z-score, or within an interval. So now we're going to go backwards. Okay, so we're gonna be given the probability. Okay, and then we're going to find the z-score from the probability. So let's do an example, okay? And what we mean essentially is, what if we want to know, just to be clear about what we're trying to find. What if we want to know the lowest score in the top 10%? Okay, so for something like this, we need to be given certain things, okay? So we want to know the lowest score in the top 10%. We would have to be given a mean and a standard deviation, right? But that doesn't mean that we can't find a z-score. So we're going to start just by finding the z-scores, and then we're going to go and we're going to be more specific with something like this, okay? So let's start with just z-scores. So as an example, suppose we want a z-score that corresponds to a cumulative area. Remember, a probability is an area. Okay, remember what we're looking for here. Here's our normal curve. And we want to know, okay, well, what is the z-score here, right? How many standard deviations? Here's the mean. How many standard deviations from the mean are we if this area is 0.3632? So we've talked about like the fact that this might be 1 standard deviation below the mean, or 2 standard deviations below the mean, or 1.2 standard deviations below the mean. That's what we're looking for here. So now we know this, and we're looking for the z-score, whereas before we knew the z-score, so we knew where this line was, and we were looking for the area. So we're going backwards. Now what does this mean? This means that we have to go to the z-score table. So we've been calling it the z-score table. Some people call it the standard normal table. So I'm going to put both down here. And I'm going to refer to it interchangeably, and you'll just get accustomed to both. So just be aware of that. So we have to go back to our z-score table, or our standard normal table. And what are we going to be looking for? 0.3632. Now, how can we find this quickly, right? Well, if you notice, I drew the line around here. How did I know it would be around there? Well, we know that once we get to the mean, this area over here is 50%, right? It's 0.5. So if I'm at 0.362, I know that I'm further to the left. Okay, so if we go look at our z-score tables or standard normal table, okay, we know that we're to the left of the mean because, or to the left or below the mean, because our value is less than 0.5. And I'm just writing that down, that we know we're to the left, which really means below the mean. Because our area is less than 0.2, is less than 0.5. Okay, which means that our z-scores are going to be negative. Okay, so we're going to the negative z-score table. So if our area is less than 0.5, the z-score is negative. And then one thing that you'll notice is as we get further and further away from 0, right? Here's 0. As we get further and further away, it's getting smaller and smaller, right? Here we're at 0.5. Over here we're at 0.0764. And then if we go here, we're at 0.0003. Excuse me. So we're looking for somewhere in between there. So we're going to be looking for 0.3. And remember that now we're looking inside the table here. Okay, so we're not looking at the numbers on the side yet. We first have to find 0.3632. So here we're only at 0.0, so we have to go further. We have to go closer to 0 here. So we're looking for 0.3632, and it's right here. Okay, let me see if I can highlight it. Nope, can't highlight it. Okay, but it's right here at 0.3632. Hopefully you can see the mouse moving. I'm sure that there's a way to highlight it. I just don't know how. And then what we do is we go to the sides to figure out what that z-score is. So when we go to the row, it's negative 0.3. And then we're going to go up to the column. And the column is 0.05. So we know that it's negative 0.35. So again, we go across. We're looking at this number here. This is a negative 0.3. That gives us our tenths place. Then we go back up here and we follow the column up and we're at 0.05. So that gives us our hundredths place. So what does this give us? What does this tell us? It tells us that the z-score for 0.3632 is negative 0.35. Okay, what does that mean? We're 0.35 standard deviations below the mean. Okay, so let's do this. Okay, let's keep going. Suppose that we want to find a z-score. I'm going to put this in a different color because it's a different problem. So I just want to be clear. We're 10.75% of the area. So remember, we mean the area under the curve is to the right. Okay, so let's think about what this means again, okay? So again, here's our normal curve. We have a z-score, and we're saying that this area is 10.5%. 10.5% is 0.1075. Okay, so this is what this is telling us. We need to find this number. But remember, our z-score table will only tell us this area on the other side. So the z-score or standard normal table. So what that means is we have to find the area on the left. Okay, so to find the area on the left, remember, all we have to do is subtract from 1. So 1 minus 0.1075. And if we do 1 minus 0.1075, we get 0.8927, right? So if 10.75% is on the right, then 89.27% is on the left. Sorry, 89.25. I don't know where I got the 7 from. Okay, so let's go back and we have to go to our z-score table. So once again, think about whether you're to the right of the mean or to the left. Now this is greater than 0.82, this is greater than 0.5. So we're on 0.8925 is greater than 0.5. So the z-score is positive. That's what we're looking for. And you would know, you would figure it out from the z-score table, okay? And I'll show you in a second why. But this makes it go a little bit faster, okay? So if we look at the z-score table again, if we're in the negatives, you'll see that the highest number you go up to is 0.5, right? Every number over here is lower than 0.5. So in order to take care of this, you know that you have to go to the positives, okay? As you get further away from 0, on the left, your z-score goes down, but as you get further away from 0 on the left, your area goes down. But as you get further away from 0 on the right, your area is going to go up, okay? And just so that you see why that happens, as we go further, remember the area is to the left. So as we go further to the right, there's more of the curve that's exposed, okay? Okay, so let's go here. We're looking for 0.8925. Okay, that means that we're probably closer to 3.4 than we are to 0, because at 0 it's 0.5 and at 3.4 it's really close to 1. So 0.8925, you're just kind of eyeball it. Okay, and actually I was wrong. We're more like at 1, we're over here. So we're actually a little bit closer. That's because the reason for that is, if you think about it, which I didn't think about it enough, this gets smaller and smaller over here, right? So as we go further and further, we're actually covering less area. We're increasing the area by less. So, right? Because here, when we increase the area, look at how much it's increasing by. When we move from over here to over here, right? It's much more area than if we move from like somewhere over here to somewhere over here. There's much less area under the curve when we're closer to the ends than when we're closer to the middle. So that's why we wind up where 0.8925 is over here as opposed to over here. So if you go to if we look for 0.8925, it's right here. I'm sorry, I can't highlight it. Don't know why. And again, we're just going to look at the z-score. So you have to go to the row first, okay? Because that gives you the larger number, the tens place and the whole number place. So we get 1.2, and then we have to go up and get the hundredths place. So it's 1.24. And that's our z-score. And that's all that we're looking for. And I'm going to box it because I didn't organize this part well. That's the z-score. Okay. Let's do another one. So let's find the z-score with 96.16% of the area to the right. Okay, now again, here's the thing. This is to the right, but we need the area that's to the left. Okay, so how are we going to find that area? Same way as we usually do. We're essentially subtracting from 100%. So we're taking the 0.9616, which is the decimal, and subtracting it from 1. So we always need the area on the left. So 1 minus 0.9616 is 0.0384. Okay. This number, this is a 3. Threes always come out with these little tails. So 0.0384. So this is what we're looking for in our z-score table, or the standard normal table. I've heard it referred to as both, so that's why I'm not so concerned. But you should know the name you should know both names so that if somebody else says standard normal table, you understand what that means. So let's go to our z-score table. It's 0.0384, so it's less than 0.5, so we're in the negatives. So again, it just saves us a lot of time, okay? So we're looking for 0.0384, and if we look here, we find it over here. And where is that? We go to the side first, we get negative 1.7. And then we go up and we get an extra 7 in the hundredths place. So what's our answer? Negative 1.77. Okay, so something else to note, sometimes the area isn't in the table, okay? In all of these cases, the area has always been in the table. If it's not, then just use the area closest to it. So I'm putting that note in here now, and then we'll do some examples where you'll see that that has to be true, okay? So if you don't see the exact area in the z-score table, and I'm going to write standard normal table here so that you can so that you can get accustomed to both. Standard normal table, which is the z-score table. And you're just using the area closest to it. Okay. Okay, so let's take another example, because these we already know. Either if we're given the area to the left, then we just take that area, we go straight to the z-score table, find the z-score. If we're given the area on the right, then we know we have to subtract from 1, and then we go to the z-score table. Okay, so, and this is stuff that we're familiar with. It's just going backwards. Instead of taking the z-score and finding the area, we're taking the area and finding the z-score. Let's take one that's a little bit different. Let's say, for example, that the area in the middle is 95%, okay? So how do we do this? So we're going to do the same thing, but this time we're going to take an interval. Now, you can't do this. I'm going to be really straightforward. You can't do this if it doesn't say that it's an area that's centered around the mean, okay? And sometimes it won't say that. It'll say, I'll show you what I'll show you another example. And the next one that we're going to say is find the z-score for which 95% of its area lies between negative z and z, where z is the z-score, right? So it's the same thing. It's centered about the mean. It's saying half of that area falls before the mean and half of that area falls after the mean, okay? You can't do it any other way. If it says 95% of the area, but it's between negative 2z and 1z or something, and if it's not in the center, you cannot do it. Okay, we can only find z-score intervals if they're centered around the mean. So we can only find areas, z-scores, so an interval of z-scores, if they are centered around the mean or about the mean. Okay, in other words, here's our curve. Okay, here's our mean. Here's our interval. This is exactly the same distance as this, okay? So we're trying to find this area. And what we're saying is that the area above the mean in the interval equals the area below the mean. We're talking about these two, okay? So these are the same. This is the area below. So on each side, it's the same. You can't have an interval that's shifted and then be told, okay, well, the area in that interval is 0.95. Now find the interval. You can't do it that way. This is the only way that you can do it as of right now, okay? So let's take an example. We are finding the z-score. This is the other way that you might see it written. 95% of its area lies between negative z Okay, so let's talk about how we do this, okay? So what we're doing is we're saying 95% falls within this interval. Well, if 95% falls within this interval, how much falls outside of the interval, okay? So we already know this because we know that if it's not inside the interval, it's outside the interval. So if 95% falls in, then 5% falls outside. How did we get that 5%? Just by subtracting from 100%. Right? We did 100% minus 95%. And that says 5% falls outside. Okay. Now, and this is why you need it to be centered about the mean, okay? Meaning half of the area is below, half of the area is above, okay? Because what we also know is that 5% is split evenly below negative z and above z, okay? Half of that 5% is below here. Half of that 5% is above here because it's symmetrical. So whatever is on the left is also going to be on the right, okay? So that's the second thing that we know. So half of the 5% is to the left of negative z, and the other half is to the right of z. Okay, now there's a key here. And the key statement is, it says half of the 5% is to the left of negative z. Well, this is what's going to help us find our answer. Because now we know what is to the left of negative z. And if we know what's to the left of negative z, then we can find the z-score. Okay, so what does this mean? We are looking in our z-score table, or our standard normal table. Z-score table is just faster to write, that's why I prefer it. For 0.25. Because if we know that this area is 95%, then we know that each of these is 2.5%. Okay, so we're looking for, sorry, 0.025. Let me rewrite that. Okay, that 0.025 is 2.5%. Okay, in other words, here's our mean. Here's our negative z. Here's our positive z. And we're saying 95% is between here and here. Okay, and what does that mean? 2.5% is below and 2.5% is above. Okay, so what does that give us? A total of 100%. Okay, 95% in the middle. That means 2.5% is below negative z. 2.5% is above z. We need to find what negative z is, right? We need to figure out what z is. So what we care about is the area to the left. This tells us we have an area to the left of 2.5. So we could use 2.5 or we could use 97.5. That would be fine too because that's to the left of z, but why do that? Why go through the trouble of adding? So let's just use 2.5. 2.5% is 0.025. So we're going to go to our z-score. We know that it's going to be negative because we're to the left of the mean. And we're looking for 0.025. And if we go here, 0.025 is right here. Okay, here's our 0.025. So what does that mean? Our z, we have negative 1.96. Now this says negative z to z. So our z is 1.96. It's positive, right? So this tells us z is equal to 1.96. And negative z is equal to negative 1.96. Okay, so it's between 1.96 and negative 1.96. Okay, let's do the same thing. Let's find the z-score for which 97.42% of the area. Remember, we're always talking about the area under the curve. Is between negative z and z. Okay, so again, if 97.42% is inside that interval, okay, that is 0.9742. Okay, so we can do, we can take a percent, it doesn't matter. 100 minus 97.42. And if we do 100 minus 97.42, this one I didn't do ahead of time. I'd like you to see me plug it into the calculator. I think that that's also helpful. So 2.58% is outside. What does this mean? That 2.58 is evenly distributed to the left of negative z and to the right of z. Okay, so we want to the left of negative z. So this means half of that is to the left of negative z. So we're looking in our z-score table. Remember, the z-score table doesn't have it in terms of percents, it has it in terms of decimals. So 0.0258 divided by 2. And if we take 0.0258 and we divide by 2, we get 0.0129. Okay, and this is always centered about the origin. about the mean. So if it's centered about the mean, we know that we're always going to be on the left when we do this, okay? So we're always looking at the negatives. So we're looking for 0.0129. And if we go here and we look for 0.0129, we get here, negative 2.23, okay? 0.0129 is here. So if we look to the side, it's negative 2.2. And if we look up to the top, we have the hundredths place, so it's negative 2.23. Okay, not so bad. Okay, let's do one more, okay? So let's find the z-score. For which 84.72% of the area is between z and negative z. Okay, so we're going to do the same thing here. We're going to find out if 84.72% of the area is between this, then we need to figure out how much is outside of it, okay? So same thing. If 84.72% is inside, then 100 minus 84.72. And if we calculate that, we get 15.28 is outside. Okay, what do? We take half of that. Half of that area is to the left of negative z. So we're going to take it in a decimal, 0.1528 over 2. And if we do that, we get 0.0764. Okay. That's what we're looking for in our z-score table. So how do we do this? We go to the z-score table. We know that we're in the negatives, and we're looking for 0.0764, and it actually turns out to be right here. Okay, 0.0764. So if we go over to the left, we see negative 1.4, and if we go up, it's 0.03, so it's negative 1.43. That's our z-score. And we say z equals negative 1.43, but this is really negative z, right? Just the way that it's written. It's not really incorrect to write z equals negative 1.43, but the way this is written, this is saying that the area is between negative z and z. So that's why I would write it like this. Okay. Okay. So now we're going to look at it a little bit differently. We're not really doing something that's very different, okay? What we're doing is we're saying, what's a z-score that corresponds to a percent? And this is just always to the left, okay? These are like percentiles. So when we talk about percentiles, percentile means If you're in the 8th percentile, it means 8% of the people who took the test scored below you. If you're in the 25th percentile, 25% of the people who are taking the test scored below you. So when we talk about a z-score that corresponds to a percent, we're always talking about to the left, okay? So let's find a z-score. So this is, I'm going to just put a little dashed line here because it's a little bit different. It's more the phrasing than the actual process, okay? So let's find a z-score that corresponds to a percent. Okay, so for example, a z-score that corresponds to 5% says 5% of the area is below that z-score. So just as a reminder, this is the same as percentiles. Okay, it's just that we're finding z-scores instead of the actual numbers, which we'll do in a couple of minutes. Okay, so the notation for this would just be a capital P with a 5. Okay, so what are we looking for? We're looking for 0.05 in the table. Because we're looking for 5%. So when we go to our table and we look for 0.05, so it's going to be negative because it's less than 0.5, we are going to wind up right between. So notice this is an example where it's not in the table. Okay, so it's actually immediately between negative 1.64 and negative 1.65. Okay, it's exactly in between there, which means that you can't really take the closest, right? Which one do you take? So because it's exactly in between, what we're going to do is we're just going to take the number exactly in the middle. Okay, so it falls exactly between negative 1.65 and negative 1.64. I'm going to take out this equals because we'll write it down here as what it's equal to. So we could take the number in the middle and you can either just, you have two options. You can, some of you are just going to see that it's negative 1.645. Some of you aren't. To find the number in the middle, this is like the median, right? You just take the average. So you don't have to do that work if you just see it as negative 1.645. So our P5 is negative 1.645. Now, if there's one that's closer, then take the one that's closer. But if it's exactly in the middle, then take the average, okay? And I'll write that again. If the area is closer to a certain z-score, take that one. if it's exactly between if it's exactly in the middle, use the z-score in the middle. Just like we did here. Okay, so let's just take a bunch of other ones. Okay, we're just going to do a whole bunch. So remember, this is independent of what the actual data is. This is always the same. So let's take P50. Okay. So remember, what are we looking for? We're looking for 0.5. We're looking for the decimal. Okay, so to find the decimal, we divide by 100. Okay, so if we go in and we look for 0.5, we already know what this is, right? 0.5 is 0 because 50% of the area is 0 standard deviations from the mean. So that we kind of already knew. So for this one, our z is equal to 0. This is saying 50% of the area is to the left of this z-score. So this is exactly the same thing that we've been doing. If we do P90, we're saying 90% of the area is to the left of our z-score. So we're looking for 0.9. And if we go to our z-score table, we know we're looking at the positives because it's greater than 0.5. And if we look for 0.9, we wind up over here, right? It's between 1.28, here's 1.28, and 1.29, but it's closer to 1.28. It's not exactly in the middle. This is only like 0.003 away. This is 0.015 away. So it's closer to 1.28. Okay. So our z is approximately 1.28. It's not exactly 1.28. That's why we use the approximate sign. But it's closer to 1.28 than 1.29. So this is where we take the one it's closer to because it's not in the table. Okay. Let's take P of 15. So what are we looking for? We're turning it into a percent. We're looking for 0.15. So if we go to our z-score table, it's less than 0.5. So we're going to be in the negatives. We're looking for 0.15. We're getting close. We're getting close. If we're over here, it's between these two numbers, but it's closer to this one. Okay, this is like 0.08 away. This is 0.008 away. This is 0.15 away. You can figure out which one it's closest to by just subtracting. Okay, 0.15 minus 0.515, 0.15 minus 0.1492. Ignore the sign. Sign is irrelevant. The negative or the positive just means it's above 0.15 or below 0.15. Okay, so just take whichever one gives you a closer number. It's this one. Some of you are going to be able to do that in your head. Some of you have to actually do the subtraction. Either way is fine. So 0.1492 is closest. Okay, so that gives us negative 1.4. negative 1.04. So be careful about that. The 4 is in the hundredths place. So it's negative 1.04. Okay. And it's approximate again. So notice we're not writing equals just because it's not exactly. Okay. And finally, let's do one more. Let's do P22. Okay, and for this one, we're looking for 0.22. We're just dividing by 100. We'll always have to look for the decimal. Okay, and again, it's just a percentage. This is saying 15% falls below 1.04 standard deviations below the mean, okay, or to the left of the mean. Here we're looking for 0.22. So again, it's less than 0.5, so we're looking in the negatives. 0.22, if we look here, we have 0.2206 and we have 0.2177. It's closer to the 0.2206. So it's negative 0.77. And again, it's just approximate. Okay. So the next thing is to transform our z-scores to x values, okay? So to actual data, okay? So we need the random variable. So it's like asking a question, okay? So if we go back to like the number of households that have televisions, okay? Instead of getting a z-score, we're going to get something that's meaningful to the data that we're given. And what's meaningful to the data that we're given is the random variable. It's figuring out, okay, well, it's one television per household. That's 25% have less than one television per household. 95% have between 1 and 3 televisions per household. So it's getting more exact about it. So in order to do this, let's start by just going back to what a z-score is, okay? So we're going to start by finding x values. So this is specific to the data, right? Z-score is applicable to anything that's normally distributed. This is specific to the data. And the difference here is that when we find the z-score, usually we know what x is and we're looking for z. Now we know what z is and we're looking for x. So we have to solve. So I'll walk you through this, right? So what we have to do is we have to get x by itself. So we're going to multiply both sides by the standard deviation in order to do that. That's going to make the standard deviation cancel on the right. So now what we have is we have z times the standard deviation is equal to x minus mu. And then we still need to get x by itself, so we're going to add mu to both sides. And what that gives us, I'm going to put the x, I usually prefer my x on the left. So x is equal to mu plus z times the standard deviation. So now it's just a new formula that we have. And this time it's solved for x because we are going to know what z is. Okay? So let's take some examples. Okay? A clinic records the weight of cats, the weights of cats, and it's normally distributed. So every problem that you see, it has to say it's normally distributed, because if it doesn't, none of this applies. So if I forget to write it for some reason, obviously we're talking about normal distribution, so you can assume it, but you need to see it, okay? And the mean is 9 pounds, and the standard deviation is 2 pounds. So in each case, let's find x given different z-scores. Okay, so this is just a plug and chug. Okay, we know what x is, we know what z is, we know what mu is, we know what the standard deviation is. So it's just a plug and chug. That's all. So x is equal to, I'll put this formula down again so that you know what we're using. Z times the standard deviation. So mu here is 9, and we'll write that up here so that you have it written in its symbols. Then we have plus 1.96 times 2. Okay, and if we plug this into our calculator, you can do 9 plus 1.96 times 2. It follows the order of operations, and you get 12.92. Okay, so this is an x value, which means that it is a measurement. It's saying when you have a z-score of 1.96, okay, meaning that's about 5% of the data, okay, is falling to the left. So this is positive. So it's actually more than 5%, obviously. It's 97.5% that I'm taking. How did I know it was 97.5? I'm just taking it from an old problem where I know it's, let's find it. Here, right? Sorry. I'm taking it from here. I remembered this problem, whereas when z is equal to 1.96, we have this much data before. So 95 plus 2.5 is 97.5. So this is saying 97.5% of the cats will be less than 12.92 pounds. Okay, that's what this is saying. Let's do another one. So same data. Here our z is equal to negative 0.44. Okay, so again, same data, u is equal to 9, and sigma, or standard deviation, is 2. So again, just a plug and tug, okay? You're just plugging in. X is equal to mu plus z times standard deviation. Okay, that's sigma. So we have 9 plus negative 0.44. I put it in parentheses because I don't want to confuse that negative with a minus sign. Negative 0.44 times 2. Okay, and if we plug this into our calculator, we get 8.12. And again, this is a pounds. So this is saying if you go to your z-score table, whatever number there is the percent that's less than 8.12 pounds. So if we look for negative 0.44, it's around here. So this is saying, sorry, for our z-score of negative 0.44. And that is here. So that's saying that about 33% of the cats weigh less than 8.12 pounds. Okay. Okay, let's let's go back to a different problem. Let's go back to the cars problem. I think this was the last lecture. Speed of cars on a highway. So it's normally distributed. I'm doing a little bit of an abbreviation in terms of what I'm writing down because these are the things that matter when you're given a problem. Okay, here you're given that the mean, if you remember from the last lecture, it was 67 miles per hour. And then the standard deviation was 3.5 miles per hour. Okay, so let's find x. Given z is equal to 0.25. So again, this is a plug and chug. It's just with different data. That's all. Okay, we need to be given the mean and the standard deviation. You can't do this without that, okay? Because the mean and the standard deviation is what makes this individualized to a certain data set, okay? So x is equal to mu plus z times sigma. So mu is 67 plus 0.25 times 3.5. Sometimes I put in parentheses, sometimes I don't. There's not really any correct way. The calculators automatically, every calculator will automatically use order of operations. So it'll do the multiplication first. So you get 67.875. That's it. And this is a miles per hour. Okay, it's saying that a certain whatever, if we go to our z-score table and we look for 0.25 as our z-score, this is the percentage of data. So this is saying 59.87% of cars are going less than 67.875 miles per hour. Okay, that's what this is telling us. Okay. And we'll do one more. Let's find x. Given z is equal to negative 1.3. So again, it's just a plug and chug. X is mu plus z times sigma. So we have 67 plus negative 1.3. The negative just is going to tell you that you're going to be below the mean. Okay, I wrote 64, but I meant 67. So if we do this, I tend to use the parentheses when I have negative signs, just because I don't want it to confuse it with a minus sign. So we get 62.45. Okay, so again, I'll write it down here. I didn't write it down for any of the others, but at least you'll have it. What does this mean? So remember, this is miles per hour. If we go to the z-score table, and find the area for negative 1.3. Okay, so let's do that. Let's go to the negative 1.3. So negative 1.3, and it's negative 1.30. We get 0.0968. So 9.68% of the cars are going less than 62.45 miles per hour. That's what it tells us, okay? Okay, so now let's do it a little bit differently. Let's say that you're being asked for something specific, but you're not being given the z-score. You have to find the z-score, okay? So it's one extra step. It's not just plugging in. It's we're giving you the information to find the z-score. Now find the z-score and then plug in, okay? So let's take an example. The scores for a police officer training test are normally distributed. So notice we're always saying normally distributed. And this time, the mean is 50. And the standard deviation is 10, okay? So we want to find the lowest score in the top 10%. Okay, so what we're looking for is, again, here's our normal curve. Here's our z-score. This is telling us that it's 10%. So we need to find what that z-score is, okay? So if this is the top 10%, then we have to find a z-score that's equal to 90%, that has an area of 90%. So if this is 10%, this is 90%. Okay, so first we have to find the z-score. And the z-score is going to be an area of 90% because we need the area to the left, not to the right. Okay. So if we go here, we're looking for 0.9. We're going to be in the positives. So if we look for 0.90, the closest thing is 0.8997. So that's what we're going to use. So 1.28. That's where we are, okay? So our z is approximately 1.28. That's as close as we're gonna get, so that's what we're gonna use, okay? And now we do exactly what we did before. So x is equal to mu plus z times sigma. So it's 50 plus 1.28 times 10. And this is 62.8. Okay, So that's the score. That's the lowest score. 62.8 is this score here. So 62.8 and above score 10%. Okay? In the top 10%. Let's take another example. And we'll do a couple with this one. So it's just this extra piece that we have to look for. So the mean cholesterol level for women 18 to 24 is normally distributed. Okay. So the mean is 179 milligrams per deciliter. I don't know the abbreviation for deciliter. Okay. And when we say mean cholesterol level, what we're doing is, just so that you're not confused, what's going on here is that they're taking a woman and they're measuring her cholesterol level over a period of time, and then they're taking the mean of that. Then they're taking another woman and they're doing the same thing, and another woman and another woman. And that's the cholesterol level that we assign to that woman. So then when we take the mean of all of those cholesterol levels, we get 179 milligrams per deciliter. And if we take the standard deviation here is 38.9 milligrams per deciliter. Okay, so we want to know what's the total cholesterol level in the lowest 1%. So in this one, we're looking for an area. Okay, we're looking for an area of 0.01. So notice here, because it says lowest, okay, the word lowest tells us we don't need to subtract from 1. So if it says lowest, we don't need to subtract from 1. If it says highest, we do. So lowest means, this is just a note that I'll put off to the side. Lowest percent indicates to the left. Whereas the highest, or sometimes you'll see like top 10%, the top percent indicates that we're talking about the area to the right. So we would need to subtract from 1. Or 100 if you're talking about percents. I'm going to put the 1 over to the side here. Okay, so here we're looking for an area of 0.01, so we're going to go to our z-scores. 0.01 is less than 0.5, so we're looking at the negative z-scores. Okay, when we look for 0.01, we fall between 0.0107, and the next one is 0.0084, so this is the closer one. Okay, so our z is approximately 2.30. And it's negative. Okay, and now it's a plug and chug. So x, I have 2.33. Hang on. On my paper, when I did it, I got something different. Negative 2. Oh yeah, I didn't go far enough. Not negative 2.30, but actually I went this way, and I should have been going this way. We have negative 0.0107. This is closer. This is closer, and this is even closer. Okay, so it's actually negative 2.33. I apologize for that. Negative 2.33. And now we just plug in. So x is equal to mu plus z times sigma. It's 179 plus negative 2.33 times 38.9. And if we plug that in, we actually get 88.36. Okay, and this is, again, milligrams per deciliter. Okay, and I keep writing that because I want you to understand that this is specific to this data. Okay, so this is saying 1% of the people have 88.36 or below. Okay, 1% of the people have a cholesterol of 88.36 or below. Okay, that's what we're saying. Okay, let's take one more example. Let's ask ourselves, what is the lowest number in the top 42%? Okay, so this is what we were talking about before in terms of lowest would indicate that it's the area to the left, so we don't have to subtract from 1. We're just going to go straight to the z-score table. Whereas here, we're talking about the top 42%, top or highest indicates area to the right. So if we're indicating the area to the right, then we do need to subtract from 1 because the z-score table only tells us areas to the left. Okay, so top says subtract from 1. Or from 100. Okay, it depends on whether you're converting it to a decimal before or after you subtract. So here it's 1 minus 0.42. Okay, so what we're looking for is 0.38. I don't know why I wrote 0.38. 0.58. So this is what we're looking for. In the z-score table or standard normal table. Okay, so let's go to our z-score table. We're going to be in the positives because it's greater than 0.5. And here we're looking for 0.58. So that's going to be very close to 0.20, right? 0.5793 is closer. This is only 0.0007 away. This is 0.0032 away. So this is closer. So our answer is our z-score is approximately 0.20. And then it's a plug and chug, okay? So x is equal to 179, or I'll write out the formula again because I have been. It's mu plus z times sigma. You don't have to write this out every time. I'm doing it here, but you don't have to do it every time. It's 179 plus 0.20 times 38.9. And if we put this into our calculator, we get 186.72. And what does this tell us? This tells us that 58% of women have below 186.72, or 42% of women have a cholesterol level higher than 186.72. It's just saying the opposite thing. And again, this is milligrams per deciliter. I encourage you to write the units when you get your answers because, again, it indicates that this is specific to a data set. It's not just, the Z is the same for everybody, okay? So in other words, a Z of 0.20 is 42% of the curve is after 0.20 and 58% of the curve is less than 0.20, okay? 58% of the curve is to the left of 0.2 standard deviations above the mean, okay? That's what we're saying. So that's for every normal distribution, but this is very specific to the data, okay? So that's what the units tells us. So in the previous lectures, we were looking for areas. Now we're given the area and we're looking to find out where on the normal curve we are, and then we specified it to a data set, okay? And that's it for this lecture.